Hi everyone, it's Xiao here. This is the first part of assembling the extrusion part. And as stated in the menu, this part is, not the video part, but the part to assemble the extrusion is the hardest part of everything. Okay, and in terms of number of steps, it's comparable to assembling the y-axis. So it's fairly long and complex. And as you can see here, in the menu it doesn't say what it is exactly, but after assemble this piece, it seems to me that it's the parts that control the filament. When the filament is heated, I think it's a flux. I think this part controls the flux. Again, as I stated previously, one of the hardest or the difficulty of assembling the 3D printer is putting those nuts into the associated holes in the 3D printed parts. And because the parts are 3D printed, and sometimes often the holes are slightly smaller than the nuts, so it's just difficult to put those nuts inside those holes. Yeah, as you can see, I was struggling doing that, and I also mentioned many times in my previous recordings. And if you do not have the time, I suggest you buy the printer straight and not to buy the kits, because it will take a lot of your time to assemble the kits. And the mechanism to control the filament flux is through magnet. So in this step, you need to use two pieces of magnet, and you need to install those magnets into the plastic parts, and in a way they repel each other, so that control and then you need to put a steel ball inside a plastic holder. So the magnets and the steel ball, this mechanism control the open and close of a tiny channel. Yeah, again, as you can see, I was using the handle of the screwdriver as a hammer, and using an Allen key as the hammer head. Okay. Yeah, the reason I did not use an actual hammer is because if you use a larger tool to do this kind of thing, you might damage the 3D printing parts. And if the parts are damaged, I think definitely it will affect the accuracy of the printing, and maybe can introduce some issues or problems down the road. But using this approach, it's quite time consuming and hard. And if some of you find a final no, a better approach to do the same thing, maybe you can put a comments in the commenting session. On the menu, each step looks very simple to do, but when you try to do it, you will find all sorts of difficulties to do those kind of things. And once you push the screws inside those holes, you might need to visually check whether the nuts is aligned with the holes. Otherwise, when you put the screws, or when you try to fasten the screws might not be able to screw into those nuts. So you just need to be aware of those kind of things. It was very hard to push the nuts into those holes. Sometimes it seems impossible, but if you try, if you you can try many times, eventually you push them in. The magnet, the two pieces of magnet are very strong, tiny but strong. Okay, you just need to insert them into the pieces and make sure when you assemble them, they repel each other. So I try to make sure the magnet is inserted fully into the plastic pieces. And that's the holder to hold the steel ball. And because it was 3D printed, so there are some like strands of 3D printed plastics. So I use Allen key to clear those things out, and then put the steel ball inside, and then attach the 3D printed piece to the larger piece. Afterward, you can see. I could see how the magnet affects the position of the steel ball, and I think that will control the open and close of the for the filaments. This is the last motor that is used for the extrusion piece. As with the motors for the y-axis, and this motor also is used to drive some kind of belts. So you need to attach some kind of pulley to the shaft. Okay. Yeah, for these parts, the number of screws is quite large. Okay, so you have a bag of screws. You need to be aware of some of the differences between the screws. So there are two types of screws. One is 18 millimeters. The other one is 20 millimeters. So you shouldn't mix the two. You shouldn't misuse one of the screw. Okay, so it's better to have a ruler with or have a matrix ruler, so you can actually measure the length of the screw, so you know exactly what it is. Or I think what these motors used for, I think these motors used to drive the filaments. That's why it's called E-axis. So the E stands for extrusion. So it controls the movement of filaments. So once I install the plastic pieces onto the motor, and the manual says that I need to align the pulley on the shaft. So to do the alignment, you need to use actual filaments, and the filament type they suggest to use is 1.75 millimeter one. And the one included in the box, that's a much thicker nylon wire, cannot be used for this step. So I open the included box of the filament, and to my surprise, the color of the filament is gray. I don't know, on the web page that I placed the order, you can specify the color of filaments you can order. So anyway, it was a gray color, so I opened it and then I cut a small piece of the filament, and then I use that small piece. I first measure it with my caliper, and then I use that piece for the alignments. It's also a good idea to have a caliper with you, so you can measure different pieces and you know exactly what is what. So I use the caliper to measure the diameter of the filament, and it was nearly 1.75 millimeters. It was around 1.74 millimeter. So basically, you put the piece of filament on top of the motor, and then you adjust the pulley up and down, and the pulley has some sorts of groove, so the groove should be aligned with the filament. So once it is aligned with the filament, then you use the thinnest Allen key to secure the pulley onto the shaft. Okay, guys, that's the end of this part, and thanks for watching, and see you guys